Alright, in the previous section we talked about finding the slope of a tangent line. And a tangent line at x equals 1 on this parabola, the tangent line would be like that. Or at 2 we could have a tangent line that looked like that. And we had to estimate the slopes of the tangent lines because we didn't have any other way to find the slope. Today we're going to talk about differentiation, and there's a rule called the power rule that gives us the slope of the tangent line. And let's see, the slope of the tangent line, the derivative. This is not the same part of speech as all this, but I need to include differentiation. So differentiation is one way to describe the process of finding the slope of a tangent line. So then we have the slope of the tangent line, the derivative. These all mean the same thing. The symbol we use is this apostrophe. We say prime, f prime, y prime. We can also say dy dx. The rate of change of y with respect to x, that's another way of saying the derivative. And instantaneous rate of change is another way of describing the derivative. And we usually say the derivative most often. So how does this rule work? So we have the function, and then we have the derivative, f prime, and this is what we do. Multiply by the exponent. So this is there's a 1 here. I'll go 2 times 1, and then 2 minus 1. So we multiply by the exponent and then subtract 1 from the exponent, and that gives us 2x. So that's called the derivative. And looking back at the first graph, we would say we were looking at what is the slope of this tangent line, what is the derivative at 1. If we want to know the derivative, we'll just do f prime of 1 is 2 times 1, and the slope is 2. So we can determine that the slope of this line is 2. What's the slope at 2? When x equals 2, what's the slope of this tangent line? So we just use the derivative. F prime at 2 is 2 times 2. The slope is 4. What's the slope when x equals 0? 2 times 0 is 0. The slope is 0. And that's how the derivative works. Alright, pause the video and try that one. So we're going to use the power rule. The function is 3x squared. The derivative is 3 times 2. We multiply the coefficient by the exponent and then subtract 1. So that's 6x. And then it says find the slope of the tangent line, which is another way of saying rate of change or derivative. We have different vocabulary that we have to know means the same thing. So f prime at -1 is 6 times negative 1, which is negative 6. So we found the slope at negative 1. Positive 2. Alright, and pause the video and try that one. So we have this equation. That's the notation for the derivative, and we'll use the power rule. There's an exponent of 1, so we'll go 1 times 7. 1 minus 1, so that's 7x to the 0, which is 7. The slope is, or the derivative is 7. And then we could say that y prime evaluated at x equals 2 is 7. So the slope is constant, and it doesn't matter what x value we use. So let's just look at, let's do several derivatives using the power rule so we're more confident with the rule. Okay, so go ahead and pause the video and find the derivative of each of these equations. So using the power rule, we multiply by 3. We'll have y prime is 3x. Subtract 1 from the 2, and we get a 2. Here we have 3 times 4 is 12. 3 minus 1 is 2. We have a 1 here. 1 times 8 is 8. 1 minus 1 is 0. And that would be x to the 0, which is 8. Here we multiply by 2 is negative 8. Subtract 1 is 1. We're done there. Maybe this one was a little tricky, but you could think of this as x to the 0. And the derivative is going to be 0 times 3 is 0. We could still use the power rule. 0 minus 1 is negative 1, but now this doesn't matter because we multiplied times 0. Another way to think of this would be if you have a constant, its graph is a horizontal line, and the slope of the horizontal line is 0. So that make a connection there. So let's just practice a little more and review some of the notation. Find dy dx. And here we have find y prime. So pause the video and try those. So dy dx is just another way of writing y prime, and if we have an exponent of 1, we're going to multiply by 1, subtract 1, that's x to the 0, so we know the derivative is 10. Here we have a constant, so its derivative is going to be 0, and that's because if we put a 0 there, we'd have 0 times 3 is 0. And we can use the power rule on polynomials. So we just do the power rule to each term. dy dx. We do the power rule here. 3 times 6 is 18. 3 minus 1 is 2. Then we have 2 times 3 is 6. 2 minus 1 is 1. Here's 1 times negative 7 is negative 7. 1 minus 1 is 0. On this one we'd have 0 times 4 is 0. So the derivative of 4 is 0, and there's the derivative of the polynomial. Find the equation of the tangent line of this polynomial at x equals 1. So here we have a parabola. Like we saw in the beginning, we're going to find the equation of the tangent line, not just the slope of the tangent line. So let's look at, to find a tangent line, we need to know the slope, and then we'll use the point slope formula. How do we find the slope of a tangent line? We use the derivative. So the derivative is 2x minus 1. Now we need to know the slope at x equals 1. Now we have the slope, and we have an x value. We need a y value too. So that could look like this. Y minus y1, m, x minus x1, y minus, this is going to be f of 1, slope is 1, x is 1, so this x value goes there, the slope goes there. We do need to find f of 1, and if you put a 1 here and a 1 there, the value is 1. Y minus 1, x minus 1. Add 1, and we get y equals x. Alright, pause the video and try that one. So we have 2x minus 2 is the derivative. Let's evaluate it at negative 2. Negative 4 minus 2. So we have the slope, and then we need point slope. We'll do f of negative 2. Slope is negative 6, and the x value is negative 2. If we substitute a negative 2 in here, we'll have 4 plus 1, so that's y minus 9, negative 6. This is a positive, that'll be a negative. Add 9, we get 6x minus 3. Alright, pause the video and try that one. Slope, point slope. The slope is the derivative, and that's going to be negative 1/2. The slope at 2 is still negative 1/2. The slope is constant, so it doesn't matter where we are evaluating it. And then we have y minus y1 equals mx minus x1. The y value at 2 is 4. Y value at 2 is 2. If you put a 2 right there, we'll get a negative 1 plus 3 is 2. The slope is negative 1/2. X value is 2. Then we'll add 2 to both sides, and we end up with the same equation that we started with here. And that's because this is a linear equation, so every tangent line is the same on a linear equation because the slope is always the same, and we just get the same thing. Alright, just one more concept and we're all done. Okay, well, we can find a derivative, but we can also find the derivative of the derivative, and that's called the second derivative. And you can just keep going to third, fourth, fifth derivative. Here we have notation for the second derivative is y double prime, or we could say d squared y dx squared. These are two ways of writing the second derivative. So if we're going to find the second derivative, let's start with the first derivative. That'll be 12x cubed plus 6 is the first derivative, and the second derivative is 36x squared. 3 times 12 is 36. 3 minus 1 is 2. The derivative of 6 is 0. So there's the second derivative. Alright, and pause the video, try to find the third derivative of this function. So the first derivative is 6x squared plus, this will be 6x to the first power, and the derivative of this is 1. The derivative of 1 is 0. First derivative, here's the second derivative, and that's going to be 12x to the 1. The derivative of this term is 1 times 6. 1 minus 1 is 0. So there's the second derivative. And the third derivative is just the derivative of this, which is 12. The derivative of this is 0. And we'll stop there.